The zeros of a quadratic. So today we've got 2 lessons to do, lesson 6 and 7, and we're going to rely on the calculator. So please make sure that you have your calculator out and on. And I will pause the video so I can have some time to type the equations in so we're not wasting time on the video. All right, so the x locations, I'm going to get my highlighter out here. The x locations of any function where the output, meaning the y-coordinate, is equal to 0 are known, not surprisingly, as the zeros of the function. So these are amazingly important in applied settings. Okay, so when they are rational numbers, okay, meaning are nice, sort of neat numbers, then they can be found by using factoring techniques. If they're irrational, then we can't find them by factoring. We'll learn a method later on this year, quite soon actually, for solving for irrational zeros. So let's consider this equation, and it's graphed here to the right. It says, what are the zeros of the function? So it says they're the zeros where the output is y, or excuse me, the output is 0, or the y is 0. It says write their x values and circle them on the graph. So I just highlighted those, and we can read pretty clearly from the graph that one is -1, and the other is 1, 2, 3, +3. All right, so those are the 2 zeros for that particular quadratic. So you want to sit and think, okay, eventually we're going to get to, well, where do those zeros come in to this equation, okay, that we graphed? It says, verify that the positive 0, meaning this one, because this is a -1, is correct by showing that y is equal to 0. So if we take that, that's all we're doing. It says, show that that is correct, that y is equal to 0. So if y is equal to 0, all right, I'm just plugging that into my equation up here, and we're verifying the 3, the positive one. -2 times 3, -3, and we get 9 minus 6 minus 3. That's 9 minus 9, okay? That truly is correct, okay? Now it says factor this expression. So we know how to factor. We're going to think sum and product. So two numbers that sum to -2 but multiply to -3, and hopefully you're thinking a -3 and a +1. So now hopefully you're starting to see how do these factors compare to the zeros that we came up with up here in A. So hopefully you're saying, oh, okay, well if that's the factor and that's a 0 and that's a factor, x plus 1, and that's a 0, how are they somehow related? So hopefully you're saying to yourself, oh, well, those are just the opposites, which is true. Okay, so x is 3 and x is -1. Well, all right. Okay, we're getting there. Now it says, based on C, determine where the zeros of this one are algebraically. Verify using a table. So they gave us a new equation, and it says determine where the zeros of this equation are algebraically. So if I think, I've got to take and I've got to factor that. So the zeros. So the zeros meaning are where y is 0. So I take and say, okay, well, y has got to be equal to 0 because that's where they cross the x-axis if I were to graph this. And now I would then factor. Sum and product. All right, it's got to sum to +3 and multiply to a -10. So that's going to tell me it's +5 and -2. So let's think about that just for a second here. What two numbers, okay, if we think of this factor, x plus 5 times x minus 2, something times something else we don't know gives us 0. Just think about your basic multiplication facts. Okay, a number times 0 gives me 0, or a number 0 times a number gives me 0, or 0 times 0 gives me 0. So I'm saying, think about this, x plus 5, what if that were equal to 0? And what about x minus 2? What if that were equal to 0? What would x equal? take this little equation here, and we'd subtract 5 from both sides, and we get x is equal to negative 5. Take this little equation here and add 2 to both sides, and we get x is 2. So it says verify this using a table. So I'm going to pause, type this into your graphing calculator, and look at the table, and we'll come right back. Okay, so here's the table to this. So here's my first 0, 2, 0. Okay, so 2 is right. And let's scroll up here and find that negative 5, and lo and behold, negative 5 is also a 0. So that's just our verification using that graphing calculator. So what is this all building up to? This is building up to our zero product law, which is pretty important in algebra. Okay, it says it's the second most important equation solving technique is the zero product law. And truly, you've known about the zero product since you learned multiplication. So what does it mean? It says if 2 or more quantities have a product of 0, meaning they multiply to 0, then at least one of them must be equal to 0. So if A times B is equal to 0, well, that could tell you that either A must be 0, or B must be 0, or they both could be 0. Okay, so that allows us to then factor something, find the factors, and set them equal to 0, and we're able to find the zeros. Okay. So looking at this quick example here, it's already factored for me. So a factor times something else equals 0. Well, I don't know if x plus 7 is 0, or the possibility of x minus 2 is 0. But what if they're both 0? So we have to assume, okay, that they're both 0, because we don't know for sure. So now I know that if I subtract 7 from both sides, I get x is equal to negative 7. That would be 1 0 to this equation. And if I added 2 to both sides there, I'd get x is equal to positive 2 for that equation. So if you took this, graphed it, and you looked at the parabola, you would see that across the x-axis it's negative 7 and positive 2. I'm going to have you try B. Okay. All right. Flip it over to the next page. That's some more important stuff. So the zero product law is remarkable because it allows us to solve equations with an x squared or higher level term as long as the expression set equal to 0 can be factored. That's huge right there, okay, that it can be factored. So it says the roots or solutions, okay, to each of the following equations by using the zero product law. Sometimes you will be instructed to solve by factoring. So the roots or solutions, that's just a synonym for the x-intercept or the zeros. So we've got lots of options here for words. So it's talking about the zeros. Is it EX? I think it's just S. Or the x-intercepts. Tons of synonyms here, okay? All mean the same thing. So if I were to take this first equation, it's already set equal to 0 for me, so I've got to factor it. In order to solve it, it has to be able to be set equal to 0, and we can factor it. So sum and product, so I know it's going to be plus 6 and minus 2. So in order for two factors multiplied by each other equal to 0, one of them or both of them have to be potentially 0. So we have to assume both of them are 0 because we don't know for sure. So x is negative 6 and x is positive 2. So we can write that as a solution set with curly brackets, negative 6 comma 2. You may see the answers written like that. So let's go ahead, pause it, and I want you to graph this equation, and let's look at it on the table and on the graph. Okay, so pause and come back. Okay, so I've got it graphed here, and when I call up my table, Control T, there we go. So right there, I can see I've got my 2 as my solution, 2, 0. And let's back it up and let's see if negative 6 is a solution, negative 6, 0. That is also a solution. One other trick on the calculator, if we didn't look at the table, you can also go to Menu, Analyze, and then what are we looking for? Oh, our new word here. We're looking for the zeros. So it starts asking you those questions. Lower bound means be to the left. Click it. Upper bound means be to the right. Click it. Oh, look at that. Do it again for the other zero. So Menu, Analyze. What are we looking for? We're looking for a 0. Lower bound, be to the left side of the 0 you're looking for. Click it. Upper bound, slide it over to the right. Click it. Oh, look at that. 2, 0. Okay, so you can verify it with the table or using it right on the graph. Okay, so I would love for you guys to do B, and that's a fabulous one, and D. Okay, so again, you're going to factor it. You're going to set the factors equal to 0 to find the roots, and then by all means, verify that on your graphing calculator. Okay, you're going to come to class with those done. All right, and I'd like you to do exercise 4 on your own as well. Okay, let's go ahead and flip over to lesson 7. Okay, so more zero product law. So let's take it and we'll do a couple of these questions in here, but it's still the same idea. Okay, so the zero products law importance cannot be overstated. Again, it allows us to solve higher order polynomials that are polynomials than just linear. So it says, of course, for it to work, we have to have 2 conditions, and I just mentioned this. We must have the equation set equal to 0, hence the zero product law, and we also must be able to factor the expression equal to 0. Sorry for my cell phone being on. All right, so let's take a gander at C. So C looks a little funky, a little odd, but you guys are used to seeing this. What do they share in common? Look at that. So they share an x minus 3 in common. Then what's left over? X plus 1 plus, don't forget that plus sign, and then 2x minus 7, and that all equals 0. So x minus 3 is one of our factors right now, but if we take a look at what's inside the parentheses in the brackets here, this is just a big combining like terms because of that plus sign. So it's x plus 2x. I know that that's 3x. And 1 plus negative 7 is negative 6. Oh, there's my other factor. So factor times factor equals 0. If we're solving for x, take those 2 factors and use our handy-dandy zero product law. Set them equal to 0 and solve for x. And yes, they always end up being the opposite of what you see there. Okay, so x is 3, and if we add 6 to both sides, so we get 3x equal to 6. We're solving for x, so we've got to divide by 3, and we get x is equal to 2. Okay, so our solution set for that one would be 2, 3 if we chose to write it in curly brackets. Okay, I would like you to do B on your own and bring it to class. So James graphed this quadratic here using tables on his calculator, and he found the graph shown below. So it's graphed for us. He can tell from his graph and the table that x equals negative 2 is one of the 2 zeros. X equals negative 2. So I'm going to, yeah, that crosses right there at negative 2. All right. But he couldn't tell what the other was because it did not fall on an integer location. So that right there is circled. Not on an integer location. So I don't know what it is. So it's something I can get an estimate. It's somewhere between 1 and 2, but I have to be specific about what it is. So it says, write down an equation that would allow you to solve for the zeros of this function. So in order to find the zeros of a function, what do we say? It has to be set equal to 0. And then it says, how does knowing that x equals -2 is a 0 help you factor this trinomial? How will it help us? So if x equals -2 is a 0, follow this, that's our 0. Work backwards now. What was it as a factor? Think opposite. What was it before we got to a solution? Wasn't it x plus 2? Make sense? We just worked backwards. So right now, we have x plus 2 is one of our factors times what would give us this trinomial back again. So let's think. X times what is going to give you 3x squared? Hopefully you're saying 3x. And then 2, we're just playing around with some distributing in our head. 2 times what is going to give us -10? And that is -5. So we were able to factor it. Now let's take that idea and say, okay, well, it's set equal to 0. So what is, oh, that's asking us in part C. And now it says solve the equation in A using factoring to find the other 0 of this function. So we just did that. So we've got this all set up for us. It's factored. It's equal to 0. Set both factors equal to 0 and solve for the x-intercepts, or the solutions. So we subtract 2 from both sides, and we get x is -2, which is what we could see. And this one, add 5 to both sides. 3x equals 5. Divide by 3. And we get x is equal to 5/3. And hopefully you're agreeing with me right now that 5/3 is somewhere in between 1 and 2. Okay? So this even allows us to find non-integer solutions. Okay? So go ahead and flip to the next page. I'm going to start you off on this one, and then I'm going to let you finish it. This one is really cool. Okay? We can explore even higher order polynomials and their zeros on a limited basis right now. So far the best we have done is x squared, quadratics. But what about x to the 3rd power? These are known as cubics. So I'm given this function. It says find the zeros of this function algebraically by factoring. So this function can be factored, and you know how to factor it. What's the first thing we look for? You should say, oh, we look for a GCF first. Fabulous, Mrs. Swenson. Yes, you are correct. A GCF. So what is the GCF here? It's x, and we're left with x squared minus 9. And then hopefully you're saying, oh, well, this is the difference of perfect squares. Ah, your math teacher would be so proud. So this ends up factoring into x minus 3 and x plus 3. Look at that. We've got a little factoring completely there. So now, how many factors do we have here? Okay. Well, if this is a cubic, my highest exponent is 3. Oh, look at that. 3 factors. 1, 2, 3. Same thing. We still follow the same rule. If we're finding the zeros, set it equal to 0. Zero product law still holds true for more than 2 factors. So look at this. This one's easy peasy. X is equal to 0. This one, x minus 3 is equal to 0. X plus 3 is equal to 0. Sorry, my dogs are barking like crazy. And if we solve this, so I see that one of my solutions is already done for me. This one is, if I add 3 to both sides, I get, sorry, I'm running out of room there, x equals 3. This next one, subtract 3 from both sides, and get x is equal to -3. 3 solutions to this. Now, I want you guys to sketch it and see what this looks like. This one's going to be kind of cool. Okay, it's cubic. It's going to look a little different, but you should see it cross at 0. It's going to cross at 3, and it's going to cross at negative 3. All right, and I'm going to have you do 4 on your own. All right, nice job, guys.